Let's start that again. We have something new today. It's the last new thing that we're going to have for this class. It's a little bit of a wrinkle to the natural deduction strategy that we've been using to determine whether or not a certain inference is valid in propositional logic. The idea that we're introducing into the mix here is what can happen when we make assumptions in our proofs. And these assumptions are things that we have to be careful with. They're somewhat delicate or risky. Let's put it that way. They're risky. You got to be very, very careful with the way that you handle an assumption in any sort of proof, including a natural deduction proof, because the whole point of giving the proof is to show that the premises lead to the conclusion without making any additional assumptions. Nonetheless, we can still use some strategies. I think we have something more or less saying the same thing here. The whole point behind a natural deduction is that I'm showing that my premises lead to my conclusion without any sort of additional assumptions. In fact, that's the point of any sort of valid argument, is my premises get me to my conclusion without any additional assumptions. If my premises are true, my conclusion has to be true. So what are we doing making assumptions? Well, what we're going to learn today is there are a couple of strategies that we can use where we kind of adopt a sort of a hypothetical stance. We say, like, what would happen if I did assume this? Show that some conclusion can be drawn in my imaginary hypothetical world. And we're going to learn a couple of rules that help us draw conclusions from that imaginary hypothetical world, where I'm making assumptions, back to my world where I'm not making any assumptions at all. Does that make sense? If it doesn't make sense, don't worry. Like, we're going to be kind of walking through it. But the whole idea here is we need a way to show that, like, the things that I prove while I'm making assumptions allow us to make other sorts of conclusions that don't involve any assumptions at all. For example, here's the first of 3 new rules that we're going to learn today, all of which involve making some sort of assumption within my natural deduction. Let's say I've got we got the big, huge natural language argument here. Who cares what the natural language argument says? Who cares about the content? I'm only concerned about the form, insofar as I'm like worried about whether or not the conclusion is something that can be validly drawn from the premises. So essentially what I have are these 2 premises. If H then D, if U then S, and what I want to prove from these 2 things is if H and U, then S and D. How many rules of inference do I already have at my disposal? We've got 8. Remind me of what they are. Modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, which we were just talking about. That's the first 4. Addition, simplification, constructive dilemma. Don't forget this constructive dilemma. And conjunction. Yeah, those are the 8 that I have so far. Can I use any of them? Can I do a modus ponens? I have conditional statements. Can I do a modus ponens? In order to do a modus ponens with these conditional statements, I need the antecedent as well, right? I have if H then D. In order to do modus ponens, I'd also need H. But I don't have H, so I can't do modus ponens yet. Can I do a modus tollens on any of these conditional statements? No, because I don't have a denial of the consequent. Can I do a hypothetical syllogism? No, I can't, because I don't have some term in common that's the consequent of one and the antecedent of the other. That's how hypothetical syllogism works, right? There's a middleman that we're kind of eliminating by going around it. I can't do a disjunctive syllogism because I don't have an or statement. I can't do simplification because I don't have an and statement. I could use addition to make big, gnarly or statements from this, but I don't know if that's actually going to get me anywhere. It doesn't seem like it's going to get me any closer to my conclusion. I can do conjunction of these 2 things, but well, notice that's not really quite my conclusion either. I would have if H then D and if U then S, and that ain't what I'm going for. Can I use constructive dilemma? Nope, because I don't have a big and statement as a premise. So what can I do? Well, here's one of the things that I can do. I can assume H and U. Well, notice that this is what I'm trying to get to. I'm trying to get to this big statement that says, if H and U, then S and D. Let's assume that H and U is the case. Now, I can't just introduce this as a new line. I can't just like invent things out of thin air and say, new premise. That would be nice, right? You could prove anything you wanted if you could do that, right? Just invent any new premise and just boop, drop it right in there. What I'm making here is an assumption, and that introduces a little hypothetical world. And I have to be careful not to confuse that hypothetical world with the real world where I'm not making any assumptions. So what I need to do is show that in my natural deduction. I'll indent a bit, and a lot of folks will tend to even like make a line, make a big vertical line that shows that everything that's going to follow here is part of a hypothetical world where I'm making some sort of assumption. I'm going to kick this whole hypothetical world off with some assumption. And that assumption in this case is going to be, I'm going to assume H and U is the case. And the justification that I offer for it is assumption. Anytime I use this assumption rule to introduce something new, I've got to indent and create a new hypothetical world in order to do that. And we can, by doing this, what I'm setting myself up for here is like if I continue to prove stuff in here, I never mistake it for something that's like an ordinary premise in my main proof. It's just something that's going on here, and I'm going to have a limited set of rules that help me kind of emigrate, to get back from my hypothetical world into my real world premises. So, assuming H and U, now what can I do? If I have H and U, simplification. I got H. And if I have H, I have U. Oh, I can do another simplification from H to U? Yes, I can. That's slightly different than the order that I set this up. But yeah, that would totally work. If I wasn't going straight after U next, what would I do with the H? Modus ponens to get D through 1,4 modus ponens. And now I can get U. And U will get me S through modus ponens to 6 modus ponens. So I've got D, I've got S. If I have D and I have S, I have... It's not hard. Let me say it again. If I have D, comma, and I have S, comma, I have S and D through conjunction. And what I've shown here is, assuming H and U, I will get S and D. Another way of saying that is, if H and U is the case, then S and D is the case. And that, my friends, is what I'm trying to prove. If H and U were the case, then S and D would be the case. The way that I get out of my hypothetical world here now is I employ a new rule that we're introducing here, the rule of conditional proof. And that conditional proof rule says, if I make an assumption, any conclusion that I draw from that, I'm going to be able to make a conditional statement that says, if the assumption, then this thing that I'm able to prove from my assumption. Does that make sense? And the way that I cite this is the entirety of the hypothetical world that I just kind of worked through, starting with my assumption all the way through the conclusion that I'm drawing from it. So lines 3 through 8 in this case. And the rule that I'm using to justify this is CP for conditional proof. And that conditional proof rule says, if I make an assumption, and I can draw some conclusion from that assumption, and I almost always will be able to, then I can make a conditional statement that says, if the assumption, then the conclusion. Does that seem about right? This needs to be all right, because this is the simplest of the 3 proofs involving assumptions that we're introducing today. Do we understand the principle here? Make an assumption, draw a conclusion. What I'm allowed to then say is, if that assumption is true, then the conclusion is true. I can make a conditional statement out of it. Okay, that's conditional proof. Here is a slightly more complicated version of a strategy that also involves making assumptions. This one is known as proof by cases. So this is our second new rule that we're learning today, also involving the use of assumptions. And the principle behind proof by cases says that, like, okay, you got to start with a disjunction. If you start with a disjunction, if we know that I have some sort of or statement already on the board, tell me, what does that mean, by the way, when I have an or statement? If an or statement is true, something like P or not Q, what has to be the case about P and Q? They can't both be false, right? Another way of saying this is, at least one of them has to be true. Do I know which one is true? It could even be both. It could be both. It could be one but not the other. It could be the other but not the one. I don't know. I know it's got to be at least one of those. but I don't know which one. Well, what proof by cases tells me is, well, I know it's at least one of these two disjuncts, so let's go ahead and assume one. Let's go ahead and assume the first disjunct and see where that gets me. If that gets me to my conclusion, I'm not there yet. I said, like, assuming that P, then I would get R. But I don't know that P is true, so I can't really get out of that assumption just yet. But I can say, like, all right, assuming that P, I'll get R. Also, assuming not Q, if I can also get R, if I can get to the same conclusion and show you that, like, I get to that conclusion regardless of which of my two disjuncts I'm assuming, and I know that at least one of those two disjuncts has to be the truth, then I can show that, like, whatever I can arrive at by way of either of the two disjuncts is something that I can conclude without any assumptions, without any hypotheses. That was a very complicated way of saying what I'm about to do right here. So starting with P or not Q, and then I have if P then R, if not R then Q. I want to prove R. It's not really obvious how I can do this just yet. Let's start with an assumption. Let's start with an assumption that P. If I have P, what else can I get? R, through modus ponens, right? 2, 4 modus ponens gets me R, and R is what I'm trying to prove. Am I there yet? No, I'm not there yet, because I'm still in my kind of like assumption hypothetical world. I don't really have a way to say, all right, so therefore, maybe I could say through conditional proof, if P then R, but I already had if P then R. That doesn't really help me out much, right? But if I also make a new assumption, not Q, what can I do with not Q? Not R, which is pretty much the same as R, right? Through modus tollens, 3, 6 modus tollens will get me R. And what I've shown here is, if I assume P, I'll get to R. If I assume not Q, I'll get to R. Line 1 told me it's either P or not Q. It's going to be one of those two things, and whichever one it is, that'll take me to R. So I can cite my disjunct that I'm kind of basing this off of, and all of the hypothetical proofs that I've done assuming those two disjuncts. And if I can demonstrate that they both lead me to the same conclusion, then I can say by proof by cases, that's the justificatory rule, PBC for proof by cases, R must be the case, making no assumptions at all. And the way that I show this is regardless of which assumptions I make, any possible assumptions on this disjunct will get me to the same conclusion. So therefore, I don't need to make any assumptions. I know that R must be the case. Amen. Yeah, you have to, so we'll notice there, one of the things that we'll notice for proof by cases is when I'm citing the lines, I'm going to have a comma in here, right? I'm going to have, first I want to cite the disjunction that I'm kind of basing this off of. Yeah, and you have to have that disjunction in order for proof by cases to work. And then, in addition to this disjunction, I want all of the hypothetical proofs that showed me assuming first one disjunct and then assuming the other disjunct, and they both lead to the same place. If I can do that, then I'm able to bounce back out of my hypothetical world into the real world and say, all right, using proof by cases, R must be the case. See some faces like people just ate a bug. Some faces, people are like, yeah, okay, all right. Yes?
So both of your disjuncts prove the conclusion, correct?
What I'm showing is either of my disjuncts would prove the conclusion, and I know that at least one of them has to be true. So the conclusion is true, regardless of which of the two disjuncts is the case.
Okay. So you are required, if you're making these assumptions, like you have to insert both variables?
That's right. Yeah, the disjunct that I'm beginning with, I need to have, if I'm going to be doing proof by cases, I need one assumption made from one of the two disjuncts on the disjunction that I'm beginning with, and it's got to lead to my conclusion. And then I've got to make then the other disjunct an assumption and show that that also leads to my conclusion.
And if one of them works to lead to the conclusion,
then I can't do the proof by cases rule. I can't get myself out. Yep, if this one got me to not R, or if I couldn't get to R from not Q, then I couldn't use proof by cases to get out of this. I would have done what my guess is you'll probably experience a little bit of today on the worksheet. I'll have just kind of like gone through a dead end. I was like, let's see if we can do proof by cases, and then like, nope, I can't do proof by cases. Shit. Well, I guess start over or keep going. Just be like, all right, that was nothing, but let's keep going. Start on line 8. Let's do something new. It's never a bad idea if you're totally lost and stuck to just do as much as you can. Get as many different premises on the board as possible. But that kind of works a little less well when you're talking about hypothetical stuff, because there are only very specific ways that you can get out of the hypothesis. We've got 2 of them now. The first one was conditional proof. Now we've got proof by cases. There's a third and final for today. Final for the semester. This is the last new thing I'm going to teach you. It's reductio ad absurdum. You might have even heard me mention it before. The whole principle behind reductio ad absurdum is if I assume that this is the case and it leads me to some absurd consequence, then perhaps it was not a smart idea to make that assumption. The most absurd consequence that you can have, by the way, for making some sort of assumption would be something that cannot possibly be true. And I know a whole category of statements that cannot possibly be true, self-contradictory statements. If I can get a naked contradiction, for example, if I can have something like A and not A and not A can't possibly be true. So if I assume one thing, can we all agree on that? A and not A, that's that whole statement. A and not A, that can't be a true statement. So any assumption that would lead me to validly conclude A and not A, or P and not P, or any naked contradiction like that, must be an assumption that is false. That cannot be the case. Anything that leads me to a contradiction is something that I can assume may be negated. And so this is a weird little indirect strategy that I can use, where if I can't find any other path to my conclusion, I can start with an assumption that is the opposite of my conclusion. I can start with an assumption that negates my conclusion. And if that assumption, the negation of my conclusion, leads me to a contradiction, then I can get out of my assumption world and say, therefore, according to reductio ad absurdum, the denial of my assumption, the negation of that assumption must be the case. So let's see that one at work. Again, I have if A or B, then if C and D. I have if C, then not D. And I'm trying to prove not A. And without wasting all of our time by going through the list of all of the rules of inference that we have, there doesn't really seem to be a whole lot that I can do here. So maybe that's a clue that I need to start making an assumption. And I'm not even really sure which sort of assumption I can make. I'm not looking to get a conclusion that's a conditional statement. So conditional proof, like making an assumption through a conditional proof, that doesn't seem like it would work. Because conditional proof always yields a conditional statement. If I make the assumption, then I can draw the conclusion, right? And I can't really do proof by cases because I don't have any really obvious or statements on the board either. There's an or statement that's buried in an if-then here in premise 1, but that's not really going to help me if I can't get it out all by itself. So maybe we try something else. Let's just assume the negation of the conclusion that I'm trying to prove. Instead of not A, let's assume A and see where that gets us. If I assume A, now what else can I prove?
That's C and D.
Skipping steps. Slow down. Before I get to C and D, if I have A, then I have A or B through addition. I got to get the antecedent of the conditional statement, right? Then I have A or B. If I have A or B, now I've got C and D through modus ponens, 1-4 modus ponens. If I have C and D, I can simplify that. Then I've got C, right? If I've got C, I've got not D through modus ponens with line 2. And also, in addition to simplifying C out of C and D, I could simplify D out of C and D. So I've got D. Look at that. Line 7 says not D. Line 8 says D. Put those two together with conjunction, I have D and not D. That can't be the case. That is a naked contradiction. If I can get to D and not D, then whatever assumption I made that led me there, that shit's got to be false. So reductio ad absurdum, and the lines that I'm citing are the entirety from the assumption to the contradiction, the entirety of the hypothetical proof there. And I say, all right, so my assumption, I must have to negate this if it leads me to a naked contradiction to make that assumption. Yes, Kristen. A leads me to an impossible state of affairs. Therefore, not A must be the case. It's an indirect proof that instead of showing that like my conclusion must be true, I'm showing that the opposite of my conclusion is impossible. It can't be the case. Assuming A leads me to a contradiction, so therefore not A. Because nobody wants a contradiction. They have to be false. Another way that I can think about this is you can do it as a, if you want it, you can think about it as a conditional proof along with an additional modus tollens. Conditional proof says, if my assumption is the case, then this is going to be the case. So if A, then D and not D. I know it's not the case that D and not D. I know that's false. So if I have if A, then this, which is false, I'm going to be able to work back through modus tollens to then therefore say not A. Get how these work? 3 different assumption strategies, one of which just introduces an assumption and says if I can draw a conclusion from that, I can make a conditional statement that says if this, then this. Another strategy involves starting off with a disjunction and saying no matter which of the 2 disjuncts I assume, they all lead to the same place. Therefore, I don't need to make any assumptions. I know that like wherever that place that all of the disjuncts lead, that must be the case. That's something that I can validly prove. And then this last one says if I make an assumption that leads me to a contradiction, then the assumption that I made must be false, and I can negate it. Got a worksheet with 6 of these bad boys on there. Working in small groups. I want to get through at least 1 through 3 on these. How are we doing on time? Yeah, we can get through 1 through 3 on these. These are not easy. So do your best to stay sharp. Get help from your classmates. Get help from me. Raise your hand and I'll come check you out. Once we get to a place where I think we have some groups that are feeling confident in their answers on 1 through 3 on the front of the worksheet, we'll pop them on the board and see how folks are doing.